Welcome everyone. Today I'm presenting the comparative analysis between the machine learning and the deep learning approaches, like specifying the contrast of sentiment qualification using the Google Play Store reviews. This study explores what method performs best under odd conditions. Let's discuss about the introduction part. The introduction part says that the digital asset transform how we shop and the communicate with the user-generated content on the platform like a Google Play. Then is understanding the consumer sentiment has become the vital as a sentiment analysis help for the business to improve the customer experience and the brand protections by the uh, interpreting those options accurately. As it says that as a result, sentiment analysis has become an essential tool for the business to extract a meaningful insight for the consumer options. Also, it enables organizing to the monitor brand predictions, also improve the uh, engagement, and also develop the data marketing strategies. Unlike a traditional shopping experience where the consumer can physically evaluate the product. And going to the next slide, like related works. So it says that the sentiment analysis can be approved to the three ways, like the Zcom based or machine learning based and the deep learning based. While Zcom method is a rules based and the lack content sensitivity, of ML and deep learning models can be run patterns from the data. Also, deep learning is a practical as shown the promise due to the abilities to understand the context and the semantics. Also, next going to the next part like a deep learning for the sentiment analysis. Let's go. Let's discuss about that. The deep learning sentiment analysis says that the deep learning method like LSTMs and transformers have advanced sentiment analysis. LSTMs solve the limitations of traditional RNNs, and also LSTMs improve the performing by the capturing both sequence and the features. And let's discuss about the objectives as a dataset and also process and also data sets processes. Let's go to the next slide. The objectives and a data set says that the objectives of the study is compare the deep learning versus the traditional ML methods. Also, it says like develop the NS and data and also evaluate the sampling strategies and also use contextual blending for the better predictions. Also, it says that assess the model scalabilities. The data set and the processing says that the source like Google Play Store is taken by 10,700 samples. Also, no, it is used for the normalizing and the segmentations. Also, like labeling, like a positive and the negative sentiment using the star ratings. So this study has several goals, like compare ML and deep learning models, or explore the improved sentiment and test sampling strategies, and also use for the contextual and learning. Also, we can use for the data set like 10,700 Google Play Store reviews for the pre-processed for the label based on their rating stars. And discussing about auto, next we can discuss about auto the models can be compared, can be used. The model used like that no Navy bases SPM logistic regressions, random forest, and the XGBoost against the deep learning models like LSTMs and the BLSTMs. This compares the previous instinct into the model's performance across the aggregate. So how can be modified? How can we get results? We can use these models and we can see the outcomes. Let's discuss about the outcomes of the results. Bi-LSTM result. The figure shows that the result, the outcome of the result of Bi-LSTM. The Bi-LSTM model says that this is the accuracy of input consistently, like reaching to 74.59 percentage, while validation accuracy peaked to 84.58 percentage. This is decrease in the trading losses confirmed and effective learning through the mirror overfitting is suggested by the validation losses. So it gives like 94% or 94.5% of accuracy, training accuracy, and the validation accuracy peaked at for the 84.58 percentage. So going to the next topic, like random forest accuracies. So let's discuss about that. The random forest performs well, especially in detecting the negative sentiments. Also, with the recall of 0.89, however, it missed the more positive samples, resulting in the trade-off. Still, it solid options where identifying the negative feedbacks is priority. He says that the actual negative are predicated negatives like 640 of true negatives and the 149 of false negative in the predicate negatives. Also predicate positive like 80 of false positives and then 591 of positive. And that the model accuracy says 84% 10% and model correctly qualified the 84.10 out of the one for an 1440 samples. And the key observation like a strong negatives, it has a positive classes and also a false negatives, also a balanced macro and the widgeted average and also negative feedbacks. It can be more critical for the situation when detecting. For going to the next topic, like logical regression accuracy. Let's discuss about that. So logical regression accuracy says that the logical achieved for accuracy of 84.79 percentage. That model shows balance of F1 scores across the classes, indicating the low basis. Also, however, miscalification rate for the still exists, especially of 0 for false negative and the 114 of false positives. So it says that the 640 of true negatives and the 149 for false negative in the predicate negatives. Also in the predicate positive says 8 for false positive and 571 of true positives. It is the figure shows that outcomes of the uh, logical regression accuracies. The SVM accuracy, the figure shows the SVM outcomes. The SVM has overall accuracy of 83.89%. It was particularly good at the recalling positive semantic. And also, it says that the class of IR indicating the favor of false arms. Also, it balanced performance in the regenerating make it a overall choice. And it says that 579 of true negatives and 91 of false negatives, and also a 141 of false positives and a 1624 of true positives. So it said a Q observation like imbalance of class detection, also a high precision of negative classes are good generalizations, also in effective with a small margin. So let's discuss about next topic like Naïve Bayes accuracy. On the Naïve Bayes accuracy says that the it is simple model use at it is still assured 83.12 accuracy. It is comparatively effective to key advantages. However, it suggests odd negative estimate detections and suggesting it may be miss more critical reviews. So it says that 591 of true negatives and the 116 of false negative in the predicted negatives. Also in the predicted positive, it says like 124 of false positives and the 604 of true positives. The key observation like a balance result also false predictions, also simple but effective, and also recall weakness for the negatives. So going to the next topic, like ZG boost accuracy. The ZG boost is qualified achieved for accuracy for 83.68% evaluations and based on the 144 test samples equally split between the two classes. So it says like positive of 611 and the true negatives of 594. There's a false positive of 124 and the false negative of 106. So it can be of some of the key observation like balance performance or input higher recall for the class one of the macro or the average for the consistency of comparing stable model behavior across the classes. It says that XGBoost accuracies. So going to next topic, ROC curve comparison. ROC curve comparison says that the curve provides the oscillostic view of model performance. The BI-LSTF leads to the AUC of 0.93, comparing to the strength in the pattern recognition. Also, the logistic regression and the random forest follow closely at the 0.92. Even similar to models like Navy basis, even remains compared. So, compared. Also, Navy base for still performs reasonably with the zero point 0.9 given for its simplicity. Going to the next comparison, last one, like a model accuracy comparison. It compares all the accuracies, model accuracies. Like Navy basis shows like 83.12% and the BI-LSTM shows 84.58 and the SYM shows like 83.89% and also logistic regression shows that 84.79% and the random forest shows that the 84 0 point percentage and the XG push shows 83 point. These are the all the overcome outputs of the models. This analysis of various machine learning models based on their accuracy of specified collective tasks, and it says that the logical regression outperforms the other with the highest accuracy of 84.79. The logistic regression is as the highest accuracy of 84.79, and the VO is identified as a performance capability, and AB has the lowest accuracy but still maintain the strong performance. These are the outcomes of the different models. So next, the code will be explained by team named Umesh. He will explain the code of the models. Thank you.
My name is Umesh. Today I will be explaining the code part to you. As you can see on the screen, I have the first cell I have included all the necessary libraries for data visual processing, model building, evaluation, and visualization. Key libraries like scikit-learn, XGBoost, and TensorFlow for deep learning. And these will support a wide variety of models, including libraries, SVM, LSTM. The second cell we have read the data. The third cell we pre-process the data we are using we filter out missing values and neutral reviews that are three because the review is one scale of 1 to 5 and sentiments are labeled as positive if it is more than 3 and negative if they are less than 3. So that data set is split into train test splitter. Next we will do is feature extraction. In this we convert text data into numerical features using count vectorize and TF-IDF. Vectorization is crucial because ML models require a numerical output, and we uh, we are using a helper function. Uh, this is mainly evaluate and print classification reports, confusion matrices, and accuracy scores. It helps standardize evaluation across all models. So the first model that was implemented in the research paper we took is Naïve Bayes. Naïve Bayes is a this Naïve Bayes we use multinomial Naïve Bayes classifier. It is simple and effective for test classifier problems, especially with the word frequencies. And as you can see, the score it is 83%, which is good uh, compared to the research paper original research, which had 73%. Next one is actually uh, with tenfold cross validation. Here we train a linear SVM model using the linear SVC. Tenfold cross-validation helps assess the model's robustness across different splits of data. For the training 10 times, and the data set itself is 10,000 rows. So as you can see, the accuracy score we get back is 84%. Next is Bi-LSTM, which is a deep learning model. This part builds this cell builds a bi-directional LSTM model using keywords. It captures long-term dependencies in text, both forward and backwards, doing sentiment understanding. So, as you can see, we are using three types: ReLU, Dana, and Sigmoid. So, uh, we get 84.5%. Next one is logistic. Next cell is logistic regression. Logistic regression is used as baseline linear classifier. It's interpretable and performs well when data is linearly separable. Let's see. Next one is random forest. We apply random forest because it is a simple method using multiple decision trees. It's effective in reducing overfitting and handling feature importance. It keep boost. This cell is XGBoost cell. This block strengths to cluster for its speed and accuracy in structured data. Uh, that's why I have used it. It uses gradient boosting and highly effective for text data when paired with EF-IDF features. So overall, when we compare the models, as you can see on the screen, this plot compares the accuracy scores. It helps the audience quickly identify which model is best for sentiment analysis. The next one is ROC curve. The ROC curve visualizes the trade-off between true positive and false positive. It provides insight into classification performance beyond accuracy, especially in balanced data. So, uh, as you can see, while logistic regression is performing well in accuracy, in ROC we can see that Naïve Bayes is performing well to positive. So, thank you.